So this is just a real quick overview of the functionality. I think most people here, if you're experienced in control systems, you understand the basic concept is to be able to look at a revision of a running application, and I'll use the term simulate, although it's more than simulation. It's doing everything that the current system is doing up to, but not including actually affecting the process. So you need to be able to look at them side by side, compare them side by side, and make that decision. Is this what I intended? Did I overlook some impact, some implication? And if I did, maybe I need to go back and tweak it a little before you actually pull the trigger. I think I've touched on that second bullet. Basically, that's that parallel evaluation. This just gives you a very high-level overview of the process. You know, we hear the terms load, evaluate, go. So you as opposed to, you know, load and go. That evaluate step in the middle is really critical. So you make your modification, you do some simulation, some offline testing, some confirmation of the change you want to make, and then you load it. Well, in a conventional system, once you load it, it's loaded and it's running. In this case, you have these extra steps in the middle. You load it into a staging area, if you will, an evaluation environment, and then you're able to do some evaluation, as I said, up to, but not including actually affecting the running process. And you can see if this were connected to the process, what would the result be? And you do your evaluation and you decide, are those modifications acceptable? Did they achieve the result that I wanted to achieve? And if they didn't, then you go back. You can basically fall back and revert. If they did, then I should say you can revert or you can decide to back out and abort. And if they did, then you take the next step and you actually enable the change. You take the go step, and then even then you have, of course, a second level of check. You've already committed, but you're still checking, are the modifications okay? And if they accept, then you want to move on and clean up and finish and go on to the next change. So what are the implications of this for the control system? Looking at it from a person who's going to have to design this. Well, there are dozens, maybe hundreds of detailed design implications that I won't get into, first of all, because I don't have the time, and secondly, I probably don't have the detailed knowledge. But first of all, you've got to take a broader view of the whole supporting of the process. It's more than just configure and load. It's a more complex process, so you've got to be able to look at it across the process and figure out what kind of support do I have to build into the system for that overall step-by-step process that we're going through. The next one is that, don't talk down into your microphone. The next one is that you have to be able to look at the configuration of the system with different views. You have to be able to look at it with current view, next view, that sort of thing. Old versus new, active versus passive, and then basically all of the different perspectives on the data and be able to look at them side by side and be able to make your determination about whether or not the change is actually what you intended. The key here is to be able to actually execute two versions of the logic side by side at the same time in parallel and do that in every sense of the word. That has tremendous implications on the design of these systems because they're not necessarily, conventional systems are not designed to do that. They run one set of code and then you change it and they run a different set of code. The other implication is the system has to have the ability to do these side-by-side checks and provide you with comparative analysis or comparative summaries of this is what this side says, this is what this side says, and be able to match the two up and determine where the changes are and if they are where you intended them to be. So for the asset owner, I struggled with this when I went through these slides. I borrowed these slides, by the way, from a previous presentation and tweaked them up a little bit. The one thing I didn't put in here is the first and probably most fundamental implication for the asset owner is to get your head around this whole concept. It's kind of the reciprocal of what I was talking about earlier. For people that have done this for years and years and years, they just come to take this as an article of faith and they think, well, why in God's name would anybody do it any other way? On the other hand, people that have never done this or never had the ability to do this, we get all the time, why is this important? I mean, we're obviously managing to get by without it, so tell me, why is this really important? Why is it something that you have to have? Or why, more importantly, why is it something that I should have? And I found, again, getting back to my comment that I'm not a control engineer, but the best way to address that question is get the real hardcore control engineers who have lived with this, talking in detail with those who maybe haven't had the ability to do this, and then help the two of them understand their two perspectives. And usually, at least in the cases I've observed, the conclusion is, yeah, this is a good thing. I mean, we need this. The other implication for the asset owner, or some of the implications for the asset owner, obviously is to be able to evaluate those differences, look at obvious differences in logic and expected versus unexpected implications. Look at also what happens after a restart of the system. You would need to be able to preserve state and then start it up and look at it and say, is it where I want it to be? Looking at the outputs, making sure that they're equal, old and new. And then ultimately at the bottom, all best plans notwithstanding, you do end up making changes that maybe have some unintended consequences, and you want to ease the ability to revert back. And having something to revert back to, because you haven't burned your bridges behind you, you've converted to the new strategy, but the old strategy is still there, so you can also switch back. So this is just if you don't have this feature, you can do some of this manually, some of it. So you have, and I'm sure that people who have done these changes, and I'm a software guy. I mean, my background is writing not control software, but software, system software. And you do this. You have the existing system, and you have all sorts of manual methods to figure out, okay, this is the way it worked the last time, and now I'm going to make some changes, and how do I evaluate those changes? This is basically an inherent tool to the control system to aid in that process. The bottom line in terms of operations is that not having this feature increases risk, because now you're making changes which you may not have or understand the full implications of those. And I talked about the load, evaluate, go, or the hot loading. There's the converse of that, or without that capability, it's basically load and go, or shotgun loading, if you will. Pull a trigger and hope for the best. And that definitely can increase risk. And you have less predictability or less capability of predicting the impact of changes. So that's a very quick overview of hot loading and why it's important to the control systems engineer, and why it's important to the asset owner and the actual operations staff. The bottom line to all of this is smoother operation, safer operation, and more predictability to the process. We all know that change is when bad things happen. So you need to have the ability to minimize or at least mitigate the effect of those changes and anticipate any adverse impact before it happens. So with that, I'll turn it back to Dave. Thank you.